This is exercise 4, surface project. It's kind of the culmination of a lot of the stuff we've been doing with Shape Studio tools. Not really just that, but after everything we've just been playing around with the Shape Studio, we're going to put to use some of those tools in a little bit of a realistic way. Mainly the X-form, where you show the nodes, the control points on a surface, and you drag the rows up and down and you shape the surface. Although, we're actually only going to do that on one part of this. We're given scan curves, and kind of like the last one we saw, this is a different model, but it's very similar to the one we saw already. There's really two slab areas. There's kind of an area in the inboard side of the hood, right there. And then there's a little step down, and then there's this surface over here. Now we're not talking about coming down the side where the fender is. We're gonna make two different slabs using two different tools, okay? One of them is gonna be Shape Studio, that's out here. But over in this area, the main slab, if you wanna think of it that way, it's a bigger piece. We're actually gonna use surfacing tools that are, if not exactly the same, but very similar to something you've already been doing in modeling. I opened up this file, by the way, and up in the top it says NX Modeling. Some of the files, and I think yours will show up that way too, but depends on how I saved it last. But some of the files we've been opening up recently, it took us right to Shape Studio, not modeling. Okay? No, this one's in modeling. If I wanted to, if you want to be in Shape Studio versus modeling, remember you can always go to File, and here's Shape Studio. Right, so if I'm in Shape Studio, I got somewhat of a different ribbon bar on the top. There is Home, but there's also something called Feature, where there's Extrude and Revolve. So, be aware of which one you're in. If you're expecting it to be modeling stuff, and it says Shape Studio, and you want it to be modeling, just go to File, and down here you'll see Modeling, right? So, did anybody open it already? What are you in?
Shape Studio.
Yours went to Shape Studio? All right, so I'll put it in Shape Studio then. I'll leave it in Shape Studio, because that's what yours is in, so you'll see the same thing. So you remember, most of the tools you can get to them either way, right? In Shape Studio though, there's the Home tab, and you don't see Extrude and Revolve, right? But there is a Feature tab, so that's where Extrude and Revolve is, just FYI, right? So anyway, the main slab is what we're gonna start with, and really what I'm showing you is it's a technique that's really used by people that do this stuff. They actually, when I was in a training group at Chrysler, the folks that did this, they wanted us to teach, a lot of the tools they used in the studio area where you had to get real fancy. So they showed us all this stuff. They showed us how to do these steps. It's a bunch of little steps. It's not just going to X-form and shaping it to make exactly the shape we want, right? It's pretty cool. There's a lot of work involved in it, but it's a real technique, so it's kind of a neat thing to learn. It does also require us to try to line up our surface with these blue curves, which again, the blue curves, these are scan curves. They're not really smooth. They're bad. We're trying to make things that lie as close as we can to those, but that is also smooth, okay? So we're gonna have to make a surface using some tools that are gonna try to line up close to that. Okay, we've also got these two lines. There's an inner feature line and an outer feature line. Those are red. You can see colors. Just another FYI, in the tree, I know I got some stuff here for my demo that you won't have yet. But in the top of the tree, these curves are not parametric. They're not in the model history. It just says spline. It doesn't say intersect or parallel or anything like that. If you got wireframe that's non-parametric, I know I've talked about this, you'll see groups up here. So there's a couple of groups. There's one called Scan Curves, which has 28 splines plus those two red ones, the inner feature and the outer feature. And then there's that scan curve right down the crown in the middle, right? So there's a group there. And then there's also a group that says offset curve, and there's one thing in there. In this exercise, again, we're sort of doing what we did last time. Remember how, there's a little crown in the middle of the hood here, this little bump. We're gonna ignore that. All we're trying to do is make a slab that goes all the way to the center of the hood, matching these curves right here, okay? Well, last time, we had this thing called offset curve, like that, but that was kind of a bad curve. We had to put a fit curve through there to make it smoother. This time, we're gonna make our own curve right here. We're not gonna use that offset. We're gonna make our own curve that's using one of these techniques that I keep talking about that they actually use in the studio, okay? What it boils down to is this, it's gonna be a lot of little steps. But they decide pretty much, and I think this is one of the first things they'll look for, if they see a clay model and they wanna make surfaces and curves that match it, they'll probably look at this and say, well, you know, that really is kind of circular right there. If we can make a circle that matches that radius really close, that'd be a nice clean surface, right? And it really is, it's close to being a circle. If I look at any one of these scan curves, just this top level, not down here, not when it goes down that step, that's a different shape. But just right here, they basically would say, you know, that's pretty much circular. But these are scan curves, those aren't really circles, those are bad curves. So we're gonna make circles that run through those, okay? And then when we make those circles that run through those, we're gonna extend those circles so that they come right down the center here, and we're gonna come up with, you'll see when I do a couple steps. Imagine a circle going through this, but it keeps going. And where that circle crosses the middle of my vehicle, right where it crosses, I want a point. That tells me where the middle of that curve will be in the center of our vehicle. Again, you'll see, I mean, I'm just talking right now. You're probably thinking you're not making sense. But you'll see when I do a couple things here, right? So anyway, that's what we're gonna start with. So I'm gonna do the first one. Basically, and we're not doing every single section here, right? The scan curves, in the X direction this way, every 100 millimeters, they cut a section through the clay model, or they made a scan curve through the clay model. Well, there's one missing here and there's one missing there, but these are every 100 mils except for that gap. So 100 mils further is that one, 100 mils further is that one, that's 200, and then there's a bunch of hundreds. Well, we're gonna put planes right where all those curves are. So I'll start with the first one right here, okay? It just basically tells you, go to the datum plane command, add a distance to the YZ plane, and the first one, I don't remember how far it is. First one's 600 millimeters from XY. This has to do with where this thing was designed with respect to the apps of origin, okay? And looking at it like this, because I'm offsetting this one, you know, the symbol's down here, but I really wanna see the symbol up here. You could do this a few different ways. You could drag this corner like that and then grab these and sort of finagle the shape of this. What I try to do is get it so it's not too big, I don't want it really big. So when I zoom in up here, you can see where it really is. See how it's going right through that first section, right there, okay? So, I mean, you can put it as close as you want, make it as big as you want, but I think it's easier to work with if they're not huge. So there's that one. So it's still it's parallel to the YZ, and it's 600 millimeters from the YZ. It's parallel to it, but it's visually, the symbol is right next to the actual curve, right? So that's the first step. Why do I have that plane? Because I want to make a sketch. Right? I keep saying, well, I want to draw a real arc. I want to draw a nice clean arc that goes through this bumpy curve. You know, if you get in there close enough, it's ugly. Can't really show the visual. The graphics don't really show it too bad, but it's ugly. I want to make a real circle. The real circles in CAD are very smooth. Well, I'm going to do it in Sketcher. It's the easiest way to do it. Okay, so I have a plane for my sketch. And a really easy way to make a circle that kind of runs through this is a circle through 3 points, and the 3 points are on there. So what we're going to do is create 3 points. Actually, in the instructions, it tells you to make all the planes at one time. I guess I can show you that. I already did it. There they all are, right? I got the first one already made. I did it twice. But at some point, you're also going to do this. I'm going to hide those. You're going to make a sketch. Well, I'm sorry, you're gonna make 3 points on this curve. Now, every one of us is gonna do this slightly different. I've done this demo a few times. Every time I do the demo, I'm sure it's a little bit different. Because where you pick, you just eyeball it. So if I go to the curve tab, here's point. I'm gonna make sure I can pick, point, I want to point on curve, okay? So when I do a point on curve, curve. Then when I go to specify the point, after all this, I was in the wrong step. I wanna pick a point on a curve. If you set the snap point to point on curve, that lets you pick on a curve, right? If I turn that one off, see, it's not letting me pick something that I know is on the curve. So if you turn on the snap point, it's called snap options here. That way I can turn that on, and I can put my cursor, if you look at, here's what my picture looks like. See, that's what you're gonna do. You're gonna look at the picture and say, I'm gonna put points right about where that is. And actually, now that I'm looking at it, I tell you to use, I didn't even have you go to the point on curve, I have you do inferred point. Because you can still do point on curve, or inferred point. Either way, it would've been the same thing. And you're just eyeballing it, right? My picture, I'm looking at the picture on my other monitor, it's about there. Okay, I'll hit apply. The next one's somewhere right about here. I'll hit apply. I'm just making 3 points, you know, kind of spread out on there. And I can now make a real arc that goes through those 3 points. Well, that'll be pretty close to that shape. Even though that shape is not a true circle, I wanna make a true circle. An easy way to make the true circle is with a sketch. So I'm gonna go to Sketcher on this plane, okay? Now you could reverse it, but if I don't reverse it and I hit okay, it looks like we're looking at it from the other side. We're now in the back of the vehicle, looking towards the front. Well, that's what my instructions show, so that's what it looks like. Okay, this is probably the trickiest part, but after you do 6 of these, you'll get good at it. There's those 3 points, okay? I wanna make a real arc. I'm in Sketcher. You went to the profile tool by default. I'm just gonna go to the arc tool. Remember the arc tool, you pick the start, then the end, and then the middle. I wanna make something kind of close to this, so, and you don't have to be exact. I'll start there, I'll end it over here somewhere, and then the middle one will be anywhere, could be anywhere, like that. So there's an arc, that's a real arc, that's a smooth curve, it's a Sketcher. I wanna try to get through those 3 points. So, in this case, I've got the 3 points already there, so what I can do then, I'll turn off arc, is I can make a point on curve between this arc and those points. Those points aren't really in the sketch, but I can use them. So if I pick the arc, and remember when you pick arcs, if you pick them one way, you're actually going to the center. It's a pretty big arc. If I pick it like that, if I see that little symbol, that means I'm going to the center point. I don't want that. I want the arc itself. So that little symbol means you're picking the arc, not the center of the arc. So pick that, and then try to do it quick. Pick that point. If you hesitate, then you gotta pick it on here. And you can still do that, just try not to move your cursor. And then there's point on curve. So there it is. And see, it's not gonna move those points because they're not even in the sketch. If you're in a sketch, the only thing you could possibly edit is the sketch. So it had to move the curve in my sketch. So there's one, now I gotta do these other ones. Again, it's faster if you pick the point quick, I mean, it's better. Pick the curve, and then click on the point quickly. I missed it, I picked another curve. Pick the arc, make sure you're on the point. Pick the center of the arc that time. Pick the arc. Now because I got it so close, it might be tricky if I do it this way. I might wait for the 3 dots and pick that point, and then pick point on curve. Right. Usually they're not that close to each other, but that's the trickiest part. You're making an arc, and you gotta line up that arc on those 3 points. So you're gonna do the constraint of an arc to a point on curve. So that arc is now running through those 3 points. It does look pretty close to that original scan curve. The other thing is, the reason I'm making all these arcs is because I'm trying to find out where they cross the center of the vehicle, right? So sometimes when you do a point on curve, it makes it shorter. It made it shorter for some reason. Just grab the end and drag it out here like that. It doesn't matter how far, doesn't matter what the other side's doing. Just make sure this side is going across the center line of the vehicle. That's all you gotta worry about. That's all I need in my sketch. I don't know what the radius is, but it matches that curve. So that's the idea. The curves we were given are not real smooth. But we can assume it's probably pretty close to an arc. And arcs are very smooth, a real arc. So we're gonna make arcs. So we do it in Sketch. All right, now I get out of the sketch. There's it's a sketch, but it's an arc. Now, that's what you're gonna do every time. I don't need to demo that every time. You're gonna make 3 more points here, and 3 more points here, and 3 more points here and here. You're gonna do that 6 times altogether, I think. And you're gonna make planes and then you're gonna make sketches on every one of them. Well, just for the sake of my demo, I already did that, there's all my planes, okay? There's all the points, I didn't need to keep, you can hide them when you're done, see, I did make all the points originally, and then I'll just hide those, and then I made all the sketches, so there's the arcs. So if I go into any one of these, it's another sketch, this one happens to be on that back plane, you know, where that cuts through the scan curves. I made the curve pretty long on that side, it doesn't matter, all that matters is it goes across the center, okay? So, instead of boring you with me making all 6 of them, I just showed you the first one, the rest of them are already done. All to get these arcs, okay? So if I hide the points, I can actually hide points that I made in my demo right now. I've got a sketch there and a sketch there, so I got all the sketches. How many sketches do I have? Yeah, I got 5 that I already made and then 6 that I just showed you in my demo, right? So one more time, why did I make those arcs? Because I need a point. Because I want to know, essentially I made those arcs because I want to know where this slab I keep talking about, where does that cut across the middle of our vehicle? Because that purple thing is where the crown is. I want to go below that, where the slab is. I think I might even hide the planes. I don't need those anymore, I think. If I need them, I'll bring them back again. So I'm going to do a point, an intersection point. There is a plane that represents the exact center line of my hood. It's the Y, or the ZX plane down here. Okay, so I'm going to intersect that plane with each sketch. You got to do them one at a time. Select curve, and make sure you pick the plane first, because when you do an intersection for a point, the second selection has to be a curve. You can't pick the plane second. It's got to be a curve. So there's that, and I'm going to hit apply, and there's the point. So all that work I've done so far was to get to that point. That's where this slab I keep talking about, that's where it's actually going to start and cut across the center line. It's below this little bump there. It's below that. Even that you can hide if you want. Yeah, I'm in the middle of something. Cancel that. You hide that guy. Okay. So I made that point. I'll go back to the point command. I don't think I didn't make all those, so I have to do those now while you're watching. So again, first I'm going to pick this plane. Go here, second sketch, hit apply. Pick this plane. Go down there. The third sketch, apply. It's the kind of thing, after you do it a bunch of times, you get faster at it. And you can sort of see, if you start hiding things, you can see where they all are. And they are coming right across the center there. I need one more. So I'm gonna pick ZX plane. You just gotta keep going back in the window and changing the field. So there, okay? So now I got a bunch of points, exactly where I think, if this was a nice clean circular slab, at least on the curved locations that they gave me, that's where they'd come across the middle of my hood, right there. I'm gonna hide the sketches. I'll hide the sketch I made manually, right there. So I've got those points. Now this is this methodology I was talking about. I'm gonna create, last time we did a fit curve on an offset they gave us. This time we're gonna make something that's even cleaner. It's a sketch. It's a conic in Sketcher. Okay, so I'm gonna go to sketch on the same plane where those points are, which is the ZX plane. Right? And here's this method I keep talking about. In Sketcher, it defaults to profile. I don't want to use profile. I'm gonna go, I think, behind the more button here. Yeah, there's a conic. Okay, I think I might have talked about conics before in the class. I don't remember if I did. What a conic is it starts in one direction and ends in another direction, and they point at both ends of the conic. They both point at some control point in the middle, right? And they're very smooth. Conics are naturally smooth curves, okay? It says, specify a start point, then an end point, and then this control point that the ends point at. So in my instructions, I say, start the first one about there. See those points in the background? I'm a little bit in front of that front point, and then the end point will be a little bit behind the last one, something like that. And then it wants a control point, and I'm gonna pick, I tell you to pick like right about there, right? This is what a conic is. It starts here, this curve and I'm not gonna spend too much time on this, but the curve starts out pointing at this point. It doesn't stay that way because it also has to point at this one. So this direction, if I drew a straight line right there, that's how this curve starts. And you can see, as soon as I drag this, they're very smooth curves. You can sharpen the bend, but if I put the control point there, now my curve starts out pointing that way. It ends up pointing that way, right? So that's what it is. That's what a control point is, right? So we're gonna hit okay. We're not done with it. And the cool thing is, even if you hit okay, you can still move that control point, change the curve around, see that? You can move the ends. Right now, I just got 3 points. It is a conic, it knows that in Sketcher, it's a very smooth curve. What I'm gonna do now is try to make that curve match these points as close as I can. And it says, take this point and that original point that I have out there in space, that one, don't move my cursor, make them coincident. So that spline that I kind of drew close to nothing, now it started exactly on the first point, and then same thing on the end. Here's my last point that I made before, and I can pick that point first. I'm gonna pick it this way, point 4, the end of that, make them coincident, okay? And here's the thing, I'm gonna show you this, and you could spend hours trying to do this, maybe not hours. Don't worry about it too much, but the idea is, here's what they do in the studio. They take this, and they try to make it run through all the points. See those points down there? Okay, I got it on that one, but it's not on this one. It's not on that one. Maybe if I move this way a little bit. Now it looks like it's through those, now it's a little bit off on that one. You'll find that there is a place where you can get it as close as possible. I mean, if you zoom in, it's gonna be impossible to get exactly on there, but I'm looking at this, I'm thinking, you know what, that's good enough. For me, that's good enough, and I don't expect you to spend too much time. Don't worry if you're not right on. You're not gonna be, this is your first time doing this. But it is a tool that they use to make a nice clean curve that runs through things that they were given that weren't clean. So I think that's perfect, there it is. Okay, I'm done with that sketch, I finished the sketch. I just have it's a sketch, it's a spline, I mean a conic, because I know it is, right? And it does say to name the sketch, I forgot, I was supposed to do that. Remember when you name a sketch, sketches automatically get names, but to really name a sketch correctly, you do it inside the sketch. There's a name field up on top. Of course, if you don't see a name field up on top, you might have to go to this little pull down here and turn on the name field. That way it shows up there. When you're in the sketch, you type in a name there, it says call it centerline sketch. It's gonna make it uppercase, no matter what you type in. And you see that's how it names it in the tree too. So that's, when I say name it, that's what I mean. Go into the sketch and name it. So I got centerline sketch, very smooth curve. If you wanna do an analysis on it, you can. You don't have to. And one of the next things we do is extrude it, but not just yet, okay? We're gonna make a surface using not really a Shape Studio tool. It's called a section surface. You know, we've done extrudes before. You just extrude that straight out. Whatever that curve is, you extrude it straight out. We can also, there is a surface tool. I can show you right now. It's another feature. I'm trying to remember where it is in this one. Oh, there it is, section surface. It's called a section surface. It's kind of like what I just showed you with the conic curve. Conic curve, there's 2 endpoints and a point in the middle that you control, you move things around, right? A conic surface is the same thing, except there's a start curve and an end curve, and then there's a curve in the middle of it that you can move around that changes the direction of that surface. So that's our goal here. And what we're gonna do is I'm gonna make a surface, ultimately, that starts from that sketch I just made. It comes out this way, but it's gonna curve down. It's gonna point at a control curve in the middle, but then it's also gonna point down to this. So, you know that red inner feature line, they call it? The surface is gonna start out there pointing at something this way. It's gonna end up over here pointing at something that way. They're both gonna point at something in the middle. I know you're going, I don't know what you mean, just do it, right? So I'm gonna do it. But that curve is really ugly, okay? So guess what, everything we just did there, not everything, it's a little different method, but what I did there to make a nice clean curve through that bunch of points, we're gonna do something similar here. Here they give us an ugly curve. One of the first things it says to do is go to the point command. Go to curve in Shape Studio, go to point. Same as what we did before, inferred. And again, there's a picture here that says, kind of draw 3 points like you see there. You won't be exact. The last time I did it, I'm sure I'm putting it in a different spot than what I'm doing it right now. So make sure the, inferred, make sure it's inferred. That way, you don't have to pick a curve. You just say, make sure it's on snap point, goal point, and curve. Okay, and then the first one looks like it's right about there. Okay, the second one looks like it's right about there. Again, you can look at your Word document to see it. Third one I got is right about here. Okay, I made 3 points. This time though, I didn't make 3 points to run a curve through them. I made 3 points to make a plane. Okay, this is another little method we're gonna use. You can do a plane through 3 points. And if you have it on inferred, you just start picking points. There is a way to go to curves and points, and then 3 points. Then, yeah, you have to pick 3 points. That's all that you pick. But you can do it under inferred. If you just start picking points, it thinks, oh, you wanted a plane through that point. Now it looks like it's lined up on the curve of that point, but I'm gonna ignore that. I'm gonna say, no, let me pick a second point. Now it draws a line between 2 points and makes the plane normal to it. I'm ignoring that. If I pick a third point, then it says, oh, you didn't care about those other lines. You just made a plane through 3 points. Right? So we made a plane that somewhat represents the plane of that feature line. Okay? You can make it bigger, smaller, whatever you want to do. So there's that plane. Okay? So I know you're going, I don't know what that's for. But here's the other thing about this technique I'm showing you. And again, I'm just showing you this because it's something to think about if you get into designing surface stuff. One thing about making surfaces, and I just was taught this by the guys that do this. We're gonna go, there's gonna be a starting curve, and there's gonna be an ending curve over here, and then one in the middle, like I said before. The best surface you can possibly have, if you're gonna use multiple curves, the best surface is if all the curves, well, if they're all exactly the same shape, that's the best surface you can have. But these aren't gonna be the same shape. But if we can kind of borrow the underlying math of the curves, if they all can kind of share some of their underlying math, that's a really good thing to do. So I know you're going, I don't know what you mean. So here's what we're gonna do. I got this plane here. I wanna make a curve right on top of that red one, but a nice clean curve. Step one is, we're gonna project the sketch we made, that really nice sketch. That's a conic, that is a real nice curve. We're gonna project that onto that plane I just made in the direction, basically straight out, okay, which would be the Y direction, along vector. Pick the Y direction. Now it's going the wrong way though. You could do project both sides, which means it is going that way. If that was set to don't do the option, it's gonna say, well, you're projecting that way and it doesn't hit that plane. So you can either reverse the direction or you can do project both ways. And it's making, I'll show you this, it's making this curve right here. That blue curve is the projected sketch. That's what I want. Okay. So, and the word, I know when these guys were teaching me this stuff a long time ago, these surfacing guys, they would say it has to have the same flavor to it. I don't know if I came up with that word, but that project right there is a project of that sketch, which is a conic. So there's a relation between those curves. They have the same flavor. They're not exactly the same, but they're built kind of from the same stuff. Okay? That's a projection of it. Of course, I want that curve to be right on top of the red one. Well, I projected it straight out. I don't know if you can see this, but here's the red one. That projection is up above it. So now what do we do? Well, this is another technique. It's really the same shape, except it's just too long. And you can see they get pretty close in the back. It's just too long. And to make a long story short, I don't know a better way of explaining this. We're gonna shorten that. We're gonna scale that curve only in this direction. I'm not gonna make it shorter this way or longer that way. I'm not gonna make it shorter or longer this way. I'm gonna shorten it in this direction. Because you can see here's the front of the blue curve, there's the red curve. It's too far in that way. We're gonna shorten it, we're gonna scale it. Actually, I forgot, there's another step I gotta do. This our blue curve, I know there's lots of curves there, it's hard to see what I'm talking about. The blue projected curve, maybe I'll highlight it for now. So it's orange. The orange one it's too high. So, yeah, I got that nice spline, I got the flavor of it over here in a project, but now I need to move it down onto the red one, down to there. That's the one I'm trying to put a new curve on top of. So we can do a offset in face of the projected curve, I already had it picked. The face is this plane, because the projection's on that plane. I know that plane goes through the red curve, because that's how I made it. So I want it to come down. In other words, it's green now, that's my project. I want it to come down. I'm offsetting it. So it goes from here to there, whatever that distance is. Okay. Well, we can measure, remember? Measure on the fly. For the distance, go to measure. Now remember, most of you have been in my NX other classes, but it was NX 11. The measure tool is one thing that's a bit different. So I'm gonna measure between things. It's set to object. Object lets me pick curves. So I wanna measure from this curve down to there, so I can pick a curve. But I don't wanna measure a curve to a curve. I wanna measure a curve just to the back here, right where it meets. You notice it's letting me pick the curve but not the end point. This is that new measure tool. If you wanna pick points when you're measuring, you gotta set this to point up on the top. It's easy to forget that. If you're doing this part of the exercise, you forget that, just call me over. And it should be around 20. My instructions, the picture shows 20.21, mine's 19.9. Why are they off? Because we picked different points when we made our original sketch. We picked different points when we made all those little arcs when I made my spline. They're all gonna be a little bit different, right? But if it's close to 20, that's good. So I just offset the projection down. I'll hit OK. So it matches. So here's my new offset of the project. And remember what I said before, the project came from the sketch, conic. So the project had kind of the flavor of the original conic. Well, then I offset it downward. So the offset of this guy, this one, it's kind of got the same flavor. It's bringing along a lot of that same underlying math, which is our goal here. Of course, again, when I get to the front of it, the offset that I just made is right there. But here's the front of the red curve that we're trying to match. So again, it's just too long going this way. We're trying to make this one match this. So we're introducing this other tool called scaling, which, again, you might not use this for a long time if you get a job in CAD, but the people that do this kind of surfacing that's supposed to look really good, they do this a lot. They'll scale a curve because it's the same curve, but with the same flavor, but just shorter in one direction. Just trust me, that's what they tell me. Right? So we're gonna go to scale curve. Who was it, over here, I think? No, it was over here at the bottom. So I'm in, again, I'm in Shape Studio, I'm in the Curve tab. Under Derive Curve and the More button, there's Scale Curve. Okay. I'm gonna scale the offset I made. Try to picture this. That's the offset. There's the original projected curve. There's the offset downward. There's the red one we're trying to match. I'm gonna scale the offset in face. Okay. I'm gonna basically keep it where it is on this end, because it's on the red curve on this end. But I'm gonna shorten it on that end. So, and by default, when you scale something, it's uniform. That means it's gonna make it shorter in X, Y, and Z. But I don't wanna do that. I only wanna make it shorter, like I said before, in this direction. So that's non-uniform. There's always three directions if you're scaling it non-uniform, okay? Well, guess what it wants? It wants a CSIS. It's gonna say, well, yeah, we'll give you X, Y, and Z to scale it, but what direction do you want your X, Y, and Z in? You're gonna specify a CSIS. I don't expect you to memorize this. Okay, it's hopefully you kind of get the concept, but it's tricky. I want to make a CSIS basically right at the end of this curve that I'm scaling. That way, the other end will scale towards this point. So I'm going to anchor this CSIS, my scaling CSIS, at the back end of that curve. So I'm going to pick right there. And the X direction, I want it to go this way to the front. And I missed something. I forgot one step. I gotta make a plane. Yeah, I forgot. I gotta make a plane first on the end of that curve I just made. Perpendicular. So I go to datum plane. Sorry about that. I thought I'd memorize the whole thing. Plane through curve, or on curve. Here's that offset that I want to scale. But first, I'm going to set something up on the end of it, right in the end. By default, when I put a plane on a curve, it's perpendicular. but it's not right at the end, I can say, well, let's put it on a percentage of 0. You could do arc length of 0 or percentage of 0. I just like percentage for some reason. Where I clicked, it was 0.05 or 0.5 degrees from the end, but I want it exactly 0. So all I'm doing is putting a plane at the end of that curve perpendicular to it. Then when I go to do the scale, and I say, I want to do non-uniform, I'm going to scale that same curve, the offset curve. But when I pick the CSIS, I want to pick the end, and I want the X to line up perpendicular to this plane, because that plane is perpendicular to the curve. So remember, you can line up planes if you pick the shaft, the XC shaft, actually pick the shaft, and then immediately pick a plane. It makes itself exactly perpendicular. Anytime you see that symbol, that XYZ thing, anytime you see that symbol, you can repoint it to things. I'm trying to rotate this so you can see. The X direction of this scale curve I'm doing is exactly perpendicular to that, which means in the direction from the rear of the vehicle to the front, I'm going to scale it. And it's very subtle. Right now it's all 1, 1, and 1. 1 in X, 1 in Y, and 1 in Z. Right? And that's what allows me to say, well, I don't want to scale it in Y and Z. Leave them at 1. A scale of 1 means keep it the same length or whatever, right? But in the X direction, which I was careful to line up, I don't want it to be all the way to 1. And this, we experimented with it to make it look good. I want that green curve. I want to scale it back so it's about where that one is. And it works out to be 93%, 0.93. Now it's not going to be right on, but that's close enough for everyone. So see the blue curve right there? That's the new scale curve I'll make it. And it's funny, if you try to make it 0.994, that's too much. If I make it 0.92, that's not enough. If I make it 0.9, well, I might be able to make it 0.9. I don't know, you could play with the numbers, but 0.93 is good enough in my book, so if I do maybe 0.9325, I don't know, that's it. Whatever, you can tweak the numbers. But 0.93 is good. Okay, so again, I'm scaling it. Where it started was green. I'm shrinking it to 93% of that length, that overall length. 93% smaller. So it's going back to there. The whole purpose of that was to make this little blue curve, it's a scale curve, right there. It's got the same flavor as that original sketch. It's been projected and offset down and scaled, but it's still underlying it. It's still got some of the same characteristics of the original. Okay, that's important. That'll make this surface we make cleaner. So after all that, I mean, you could probably do it faster than when I did it because I was trying to explain it. You just do what it says in the book, you do it faster. All right, now, remember how I said we're going to have, and maybe just for the sake of this, I'll hide the original projected curve, I'll hide the offset curve, and all I got left, I mean, you could even hide the red inner feature line just so you make sure you pick your scale. The scale curve is the important one, all right? That's what we're going to use for our new surface because it's a nice clean curve. But we're going to make, like I said, a conic surface. So this conic surface is going to start on our sketch, it's going to end on our scale curve, it's going to point at something in the middle. Okay? And again, without getting too much detail, all I know is, remember I keep saying it's going to be kind of a circular sketch. Kind of, right? But, I'm sorry, not circular sketch, a circular surface, but not exactly, it's actually going to be conic. But all I know is, you know, we're designing half of the hood, and we're not worried about that bump in the middle, that crown. Whenever you see a hood, you don't want it to have a crease in the middle, right? You want it to be straight across. You want it to be tangent, right? Every hood you've ever seen. I mean, they might put a feature or something in there, but the main slabs, they're exactly tangent where they meet. In other words, the direction right across the middle has to be straight in the Y direction, okay? So I'm going to make a surface, my new surface is going to start out in the Y direction. It's going to curve down to meet this guy, but it's got to start out in the Y direction. Well, you know that curve I keep saying we're going to put in the middle? I need a curve that's exactly at the same height in the Y direction. So anyway, that I'm letting you know why we're doing the next couple of steps. Finally, I'm going to make an extrude of our nice pretty sketch right there. 600 mils, 0 to 600. You really should pick, for the vector, you should pick the Y or the, I don't know if I picked that. You could pick the ZX plane or that. You know what, it's a sketch, it's doing normal to the sketch anyway, so that's fine. So 600, okay, now this is a construction surface. That's going straight out. If I hit okay, that's an extrude. Extrude always goes straight. But it's starting out in the direction I need my new surface that's gonna be underneath it, right? So again, here we go, more, I'm gonna hide that point too, more construction stuff. And I'm gonna make that translucent. Best way to make it translucent is go to View, go to, if you got an object field there, go to Edit Object Display, then pick the surface, make sure you pick the surface, and then hit OK. It's not very intuitive, you gotta hit OK, and then make it translucent. Now, that one I don't need to see too much behind it, but I do wanna see some of the curves, because the next step is we're gonna make a curve somewhere in the middle of this. That's gonna be the middle of that conic curve, right? Again, the conic surface is gonna start here, end here, run through, or point at some curve in the middle. So that's what we're developing. So, guess what I'm gonna do? I'm gonna make 3 points. Here's another picture. See, that's why I had to make it translucent so you can see those 3 points. These will be 3 points on a surface. So if I go to our curve and I go to point, go to inferred, but this time I wanna make sure I can do a point on face. In fact, I'm gonna turn off point on curve, because if that's on, it might accidentally try to put points on the curve. I want point on face turned on, point on the curve turned off. Okay? Then it says make one right about here, and everybody's gonna do this different. I think one of them's right about there. 1 point. The other one's over here, and this bigger area right about there. Oh, I didn't hit apply, sorry. I'm gonna start all over again. There's one. I'd apply, there's another one. I'll apply, and then there's a third point, because yes, we're making another plane. Okay, so now I got 3 points there. What are those for? Just told you, I wanna make a plane. Plane through 3 points. But this one says turn the settings, turn off associative. Okay? Meaning, we're gonna create a plane through 3 points. I'll just pick those same 3 points I just made. Inferred. That point, that point, that point, okay? But it's not associative. That means it doesn't remember it came from those 3 points. That's important because we're gonna actually move that plane later by just dragging it. If we're moving it. If it was through those 3 points, you wouldn't be able to move it. So we made it non-associative, okay? Just stay with me, that's why we're doing it. Now, I'm gonna make that curve I kept talking about for our conic. We got the start curve. How many times have I said that? We got the end curve, it's a scale. We need one in the middle. Okay, that's gonna be an intersection, intersection curve between that extrude I made and that plane I made. Now that's gonna be associative. Okay? That plane now is driving that curve I just made. That curve, see if you can picture this with respect to what I was talking about with the conic. I'm gonna make a new conic that starts out here and it points at this curve, and because that curve is on that extrude, it's always gonna stay at the same level. That curve will always be straight out in that direction, so my conic surface always starts out straight out in that direction. I don't know if you can grasp what I'm saying. After it passes that, it's gonna start bending down to this side. So anyway, that curve is on an extrude that's always exactly out in the Y direction. So anyway, I know I said that like 3 times, all right? So, what are we gonna do with that? Now we're gonna make, do I tell you to call that? Yeah, it does say, I didn't rename a lot of things, but this says rename this to apex curve. And that's gonna come into play when we create this conic surface, which we're about to do. Now it does say in my instructions, ensure the, you know, I'm gonna hide that surface here. Ensure you're in the Shape Studio application, so if you're in modeling, I guess you should go to File and pick Shape Studio from the list, right? Then it says, go to Home tab, Base Group, in the More Gallery, and then you'll see Section Surface, there's a sweep area, Section Surface, okay? So, when we were in Sketcher, we were able to make conics. With surfaces, you can make conics or circular surfaces or cubic or linear. We want to make conic, okay? In other words, we want it to start in some direction from here, and end in some direction from there, and point at something in the middle, right? That's a conic. There's different ways to do a conic. We're gonna do the type called a rho, R-H-O. That's a Greek word, I don't know what it really means, but I try to sound smart. Because if you do rho, that means you pick a start guide and an end guide, and if you do by apex, you have an apex curve. So think back, when we did the sketch, I had a start point and an end point, and a control point in the middle. For a surface, it's a start guide and an end guide. They don't call it that, but it's a control curve in the middle. They call it apex curve. It's the same concept. It's just three-dimensional. So the start guide is going to be my sketch. The end guide is going to be my scale curve. Make sure you pick the scale curve. They're both going to point at the apex curve. Make sure it's set to by apex. And it's that intersection I just made. Okay. Now it doesn't create it yet. It needs a little bit more information. It says we need to pick a spine. Okay. And I could talk for an hour talking about what a spine does for surfaces. If you do surfacing, you'll learn what spines are. They control, even more than what we're doing here, they control the shape of a surface, right? This is going to be a conic surface. So in other words, it's going to start out in some direction here, point at that, but then it's going to point at that and end this way, right? So if you cut a bunch of sections through it, you'll be able to have a bunch of conics this way. Those conic sections have to kind of line up with something. So basically, if I were to cut through this surface in a bunch of directions this way, I'd see a bunch of conics. So what do I mean? Why did I show you that? Because the spine, if we pick X for the spine, again, you won't remember this, but we are gonna pick X for the spine. That means put an infinite number of planes perpendicular to X going like this. And everywhere you cut a section through that surface I'm about to create, those will all be conics that way. Again, you're like, yeah, okay, what is that gonna do? Why do we have to do that? I'm not gonna go into more than that, just that's what it's doing. So we're gonna say the spine is by vector, it says specify a vector, I'm gonna pick this. And now it has enough information. So again, if I were to cut sections through here with planes perpendicular to that, every section would be a true conic curve. Anyway, so there it is, there's the conic surface, okay? I already hid the extrude. The extrude's still there, but it's going straight out, right? See, the extrude is going straight out from the middle, going straight out. The conic is starting out in that direction, but it's bending down because it also has to meet the scale curve down there. And so the direction of this conic surface, it starts out pointing at this curve. The direction over here starts out pointing at that curve, but then it does its thing, bends between them. That's actually a very smooth surface, okay? Well, it doesn't exactly match, or doesn't match the sections. Doesn't match the scan curves, I should say. Well, guess what we gotta do? First, I'm gonna do this. I'm going to make it so you can see through it a little bit. Same thing I did before. Edit object display, pick that, hit okay. This is a new surface, so I gotta put translucency on that one. And you could, the more translucent, the easier it is to see things, right? So I can see those, but remember how when we did the X-form stuff, I can move this surface somehow, however I'm gonna move it, but it's really hard to tell if you're on the blue curves. Remember what we do? We do an analysis, section analysis. That surface, mine's already perpendicular to, in the X direction, perpendicular to X, okay? It's putting, I don't wanna see this, I don't need to see the comb, I just want the curves. And in the book it tells you to do every 100 mils, like that. Remember that? We've seen this before, red curve, right? On the surface. Yeah, I'll leave it on 100. If you want, you don't have to do every 100, you can do every 200. But I'm gonna hit okay. So now I can see, yeah, my surface is where the red curves are. It's supposed to match the blue curves. So we've seen this before, right? But I'm not gonna use X-form. Okay, this method that I'm trying to show you here, I might even hide that intersection. I'm gonna hide that. I even hide the points. Okay, just make it cleaner looking there. How can we change this surface without using something like X-form? Well, it's a conic surface. It starts on this curve. It ends on that curve. It's running through that intersection curve. Maybe I should show it because that way you know which one it is. if I change any of those curves, my surface will change. The method we're using is, I wanna move that middle curve around. Okay? The way I'm gonna move that middle curve around is by dragging this plane, because remember, that plane, it's intersecting to make that curve. I know, that's a lot to think about. So we're gonna do this. That's why we made the plane non-parametric, so you can drag it. So here's what you're gonna do. I'm gonna go to Move Object. You go to Tools, Move Object. Okay. The object I wanna move is the plane. I'm gonna move it dynamically, meaning I'm gonna use that symbol there. There's that guy again. You see the thing a lot. But I wanna start out lining it up so that the Y is tied to the plane. It's not exactly lined up with the plane right now. It looks like it is, but it's not. We can say, you know what, let me line up this guy, because right now if I move this, it's moving the plane. See that? It's actually moving the plane. But I want to move it more true to the plane itself. So before you move it, you can say, let me just move the handles. Let me kind of line up the handles with something first. And something like we did before, pick the shaft of the Y, and immediately pick something after it, like a plane, and it lines that up, and sometimes it goes one way or the other. It doesn't really matter what way. If you want to double click, you can reverse it. Either way is fine. But that Y vector is now lined up with the plane. Now I lined up the handles. You got to turn that back off. You also want to set this to non-associative moves. If you try to move and do an associative, it's going to try to copy and make a new one. We don't want to do that. We want to move the original. This can be on or off, move parents. Just make sure you turn off associative. And I'm going to drag that. I'm actually moving the plane. Okay. Doesn't look like anything changed, but if you hit preview here, show result, my surface just changed. Watch, I'll undo it. See? Watch the red and the blue. If I preview it, it looks like I went too far. Okay. So every time that's what you're gonna do. You're gonna play with this. You're gonna move it. Like if I move, because when I move this, what I'm really doing is I'm moving that intersection curve, which is the middle curve, the control curve of my conic surface. Now I made it bulge out on this side a little bit because I moved that. That's the curve that's both sides of my surface are pointing at. Well, if I move it over to the right like I did, now it's pointing a little higher on this side, not so much on that side. Okay? So you have to hit the preview every time. What if I go way over there? Now it went too far down on this side. It looks really good right there, but that's about it, right? And yes, you can actually rotate. If I go to this little sphere between the two handles, you can rotate that plane. Maybe that makes it better. No, that looks pretty bad on that side. Well, let me do this. Let me try to move it like this then. Move it over that way. Preview that. Now, when it's all said and done, that looks pretty good actually right there. Look at that. That looks nice. When it's all said and done, I don't care if you line it up really close or not, because you're gonna have the same issue. Yeah, I got it lined up in the front now, but when I go look at the back, now it's not lined up very well. So you could spend, if not hours, at least many minutes trying to line this up in a better way and put this exactly where you want. I mean, you could rotate it this way, see what it does, right? So you'll do, just play with it. That's all I'm trying. Just try to get it to do what I'm doing there. Once you think, oh yeah, that's good enough, just hit OK. And I actually moved that, intersection curve by moving that plane, which changed my surface. That's pretty much it. That's how I want you to kind of play with that surface. That's a real technique that's really used by real good surface people to try to match scan curves, right? You can, if you want, you can hide the analysis. Okay, in fact, I think at this point, oh no, you don't hide everything else yet, but you do hide, you can hide a bunch of points. Don't need, I can hide the intersection curve. I can hide, if you want to just do it here, you can hide the red one there. Actually, even that one, I'll hide it. Anyway, so that's the first slab. This one I'm going to do a little bit faster, because you've already done this before, okay? That side we'd use a whole new technique you hadn't heard of. We did a conic surface. This side, we're gonna do something you have heard of. I'm gonna make a curve, extrude it, and then use, X-form to bend it, twist it. Of course, that's a bad curve that we were given, so before I do that, this is what we did last time. We did a, fit curve. This time we're gonna say do degrees and tolerance. 5 degrees and a 0.1 tolerance. That means I'm gonna make a curve that is a spline that runs through that guy, but it's only 5 degrees, so it's somewhat smooth, and it doesn't get any more than 1/10 of a millimeter away from the curve. That's what that means. So I have a picture where I say, pick these 6 points. Yeah, pick 6 points about right where you see there. Okay, and make sure you're on point on curve. Okay, am I on the right one? Specify points. So somewhere here. Again, I'm not. I hesitated. I'm gonna do it fast because every one of us is gonna do this different. Something about there. All right. There, I made a fit curve. Beautiful curve. I'll hide the red one just to be safe. Okay. There's a nice clean curve, fit curve. Okay, what are we gonna do with that? We're gonna extrude it. In Shape Studio, go to Feature, go to Extrude. And now that one, because it's not a sketch, it doesn't know what direction to go by default. So I'm gonna say, I think this one I tell you to use the ZX plane. Reverse it if you want. And I also tell you to go 350. Okay, there. Now we're gonna do what you've done a bunch of times. I don't really have to spend too much time on it, but if you want, you'll intersect. I mean, you'll do the analysis where you put the red curves on it. You will make it a little bit translucent, so you can see not just your red curves, but you can see those curves. Then you're gonna go to Home, you're gonna go to X-form. You can experiment with that surface. Right now it's 1 degree in that direction because it's an extrude, right? Do I have, you know what, I gotta reset that window. Because I had a tangent on that side. Remember what I had last time? Usually it's like this, so many degrees this way. I don't need 8 patches that way, I'll smooth it out a little bit. Remember, you can do that. I'll give it, well, and remember, if you only got 1 degree this way, it's pretty stiff. If I try to drag this, the whole thing's going down there. That's not good. So remember, you can hit undo, give it a couple more degrees, drag it, right? Remember, the whole thing is dragging, but not all the points. Of course, now that's too flexible on that side. Oh, and you also want to go in the WCS direction and the Z direction. Okay. So you're going to play with it like that. It's going to tell you, then try, remember the old proportional thing? So let me undo till it's flat again. Remember the old proportional one? You can say, yeah, but let's do, try linear. And now they're all moving. Yeah, but they're still too stiff. Let's undo that. Let's do the, let's do the proportional, but the concave. And these are moving just slightly. You'll have the red curves on there too. So somehow or other you get it something like that, you might do that 1 point corner. I'm not gonna be nitpicky about how close you make it. You're gonna make surfaces like that. So this one we made with a new technique. That one we made with a X-form technique. Then I tell you, go to the groups here and turn off all those splines. I can hide that fit curve. I need that extrude. That's playing back. No, that's okay. Then we're gonna fill in this transition. This is a new tool too that you haven't seen before. And I'll say this. When I learned from the people that worked in the studio that made this, they didn't have this tool. They actually would create tubes and intersect the tubes with surfaces and then use those intersections to make blends. You're going, what do you mean? What are you talking about? That doesn't make any sense. I'm gonna show you this tool. NX came up with a tool that uses all the steps that these people did. They asked them to do this and they did it. So first I'm gonna put a temporary surface between those two. There's one called a bridge. So, is it in the Home tab? Yeah, in the Home tab, the more button over here, there's a bridge surface. This is a little bit too simple, but I need something to start with. So I'm gonna say, let's go from one of these edges to the other edge, and it's making a nice surface. You can make it tangent where it starts, tangent where it stops. I think that's what I have you do. Yeah, they're both tangent, okay. That's a temporary transition surface. But it's not as smooth and clean as what the hood surface guys liked, people. They wanted to control a little bit more. They want to make a blend starting here from this slab and go into that transition, but they want to control exactly where it starts and where it stops. And for whatever reason, I don't remember the history why, but if the blend starts and ends across that seam right between them, kind of an equidistant location, that's the best thing. So in other words, you could say, well, let's take this, let's put a curve here, parallel this way and parallel that way, same distance, and then blend from those two curves. Well, there's a tool that does that for you, okay? It's in, is it in here? Yeah, it's called Styled Blend. It actually makes tubes behind the scenes. They came up with this tool that does what all these studio people used to do. They would do a bunch of steps. Now they do it all in one command called Styled Blend. So it's asking you, and we have to do it twice. I'm basically gonna make a transition right here between these two, somewhere on here to somewhere on here, okay? Face chain one, I'll pick that, which is all one sheet body right now. Face chain two is this guy, and you can kind of see it, yeah, it's gonna blend down like this. So those arrows should both be going down. Here's a funny one, the center curve. It's gonna make a tube centered around your center curve. This is weird, I don't know how they did this, but if you select where it says center curve, it doesn't really need one. If you don't pick one, it takes the seam right where they met. So here's the seam where those two surfaces meet. So that's what it's using as the center curve. I could pick a different one if I wanted, but I even said, no, I wanna, where they meet, I wanna kinda come in both directions the same distance. That's what it's doing. And it's actually, you can already see it, previewing it. It's starting, there's a new blend right here, that's the new blend. It's starting right here and ending right there. So again, here's the original seam. It's starting a certain distance from there and a certain distance from there. You know what that distance is? It's a tube that's going around the center. 10 mil radius tube, and where it hits this surface and that surface, that's where it makes those curves. That's where it makes the starting and ending surface. I think we use a 20 mil tube. So if I make it 20, that's right. If you imagine a 20 mil tube going across along that seam, one end of the tube slices over here, the other end of the tube slices over there. If you want to, you can go down here to show, and you can say show that tube, and there it is. You don't need to see it, but that's a neat picture because that's what these surface guys used to actually create. They would actually create a tube. They'd make a curve where the two surfaces met. They'd create a tube in a different operation. Then they'd intersect the tube with this surface and that surface in a different operation. Then they'd make a blend from there to there in another operation. This thing does it all at once. This thing called Styled Blend. Okay. Now there's one other thing that you don't have to show the tube if you don't want, but under blend output, by default, it makes this new little strip right here, but it doesn't trim the originals and sew them all together. That's what no trim means. We want to do it all in one step. We want to say, it tells you this in the book. It says go to blend output. Yeah, in the blend output panel, set the trimming method to trim and attach. That means it is going to trim this one right there. It's going to trim this one right there. It's going to make this new one, and it's going to sew them all together, all three of them. So if I hit OK. Now that's still separate. That guy's still separate. This just made these three sewn it together. If I hide this one, see, all three of those are all one. That's what we want. Of course, I still got this guy. Well, we're gonna do one more of those. So again, I'm taking longer than you are because you're just gonna do the steps and boom, you're done. I'm gonna make another style blend where this one meets those. So again, I'm gonna make a little strip over here somewhere. So face chain one, I'm gonna pick that one. This one, it's weird because the arrows seem not real intuitive. I think it's not gonna like that. I think this arrow, I forget, we'll see. Just pick center curve, but don't pick one. See, it says no intersection. No, it's not that one, it must be this one. Yeah, if you point that one up and that one down, it seems to work. I don't know why, but it's just the way it's calculating it. and the numbers are all from the whatever I did last time. I got a single tube, 20 millimeters, so it's doing the same thing. It's, you know, that sheet body I had a second ago, it's intersecting it here. The X-form slab, it's intersecting it here. It's putting a strip between the two, and it's gonna, hopefully, you got trim and attach them both together. There they are. That's all one sheet body. Okay. Oh, I forgot something. When I did the style blend, I forgot. You're also, there's a setting in here for the continuity. Right now, they're tangent where they meet. From there to there, it's tangent. From here to there, it's tangent. We want them to be curvature continuous, which is even prettier. Okay. So what that means is where this surface meets that, they're the same radius. They're not just tangent, they're the same radius. Same thing on this side. Now, I didn't do that to this one. This one, they're just tangent. I'm gonna try something. I mean, that's pretty much it. You're gonna do an analysis to verify something, but let me show you. I just wanna see if I can show you this analysis. Because remember, section analysis, I don't need that many curves. I'll do every 200. Okay. If I show the comb, suggest scale factor is a little bit too big. Okay. You can sort of test, it's still gonna be a little bit tricky here, but this side I made it curvature continuous, right? You can tell, I know it's hard to see it, but you can tell the curvature. Let me add some more needles. Actually, you can kind of tell there, if I suggest it. Well, the curvature, the needles here, they're really small here, I know, they're tiny. They're too small. The needle, I don't know if you're gonna say, I don't know what you're trying to show me. Notice over here, I'll just say it like this. Notice over here, here's the end of that, the first styled line. Here's the other end where it meets the next surface. You can see the curvature on this is changing, it's getting bigger. And this one, it's kind of constant, but where they meet, the needles are the same height. Where these two meet, that's curvature continuous. That's what, when you look at an analysis, and you want to know if it's curvature continuous, when the needles are the same height, at least where they meet, that means they're curvature continuous. On the other end over here, they're tangent, but they're not curvature continuous. So here's the end of this one. The needles, you know, that's actually, I guess I can look at this exactly down the end here. Right about there. The last needle on this surface is right here. That's its curvature. The first needle on this one, it's this long. So the curvature on this surface is not the same as that one. That's not curvature continuous. When they are, it looks more like this. You know, the length of the needles are the same where they meet. When they're not the same length where they meet, they're tangent, but they're not curvature continuous. And the reason you know they're tangent is because these are lined up parallel, right? The needles are actually perpendicular to the surface. So if the two end needles are parallel to each other, the surfaces are tangent. But because the needle lengths are different, they're not curvature continuous. Anyway, that's it. That's basically it. Questions? You might not, you might get a job and work in CAD for a long time and never use those tools. But it's something that they wanted us to show in the upper body class. It's some cool styling kind of tools that, I mean, you might also do that. It's pretty cool. It's hard to get into those jobs, but those are the guys that they think they're artists and they don't let anybody else in the group unless they get familiar with it. I shouldn't say that, they're all good. What am I saying? Okay? Make sense? Question? I don't know if what you're saying, yeah, it makes sense, or if not, I'm gonna quit.